morning, my dear students. So again we are on the last class we were discussing about equivalent mass, and that too with respect to an oxidizing agent. And in the last class we discussed what is oxidation. I hope you remember oxidation is nothing but loss of an electron. Now here we are talking about how to find the equivalent mass of an oxidizing agent. Okay, so I told, right, oxidation means loss of electron. So who is an oxidizing agent? Oxidizing agent is a compound or is a person, or you can take it like anything. It's a species that perform oxidation on another person. Say for example, you have A and B. Okay, A and B. So here I consider A as my oxidizing agent. Assume. Okay, so this person performs oxidation on whom? B. So what will happen to B? B will lose electrons. Correct. If B is losing electron, where this electron will go actually? So this electron will be going to, or the lost electron will be gained by A. So now tell me, now it is easy to understand. An oxidizing agent is an agent which performs oxidation on someone else, so that someone else will lose electron and oxidizing agent will gain the electron. Okay, so that is the reason why. Now if you see the equivalent mass of an oxidizing agent, how to find out that? The molecular weight of the oxidizing agent divided by number of electrons gained by one molecule. This is very important. One molecule. Suppose in the balanced chemical equation there will be two molecules, and the number of electrons gained will be shown for two molecules. You need to find for one molecule. Very important. This is one point where majority of the students make a mistake. They will take the electrons as such seen in the reaction and substitute, but don't do that. You should find out whether the balanced reaction is shown for one molecule. If it is not shown for one molecule, find out for one molecule the number of electrons gained by one molecule. Okay, so I hope you understood what is oxidizing agent. So oxidizing agent is a person who performs oxidation on someone else. So how it performs oxidation? It will remove the electrons of B, so that electron will come to A and B will lose electron. Okay, so I hope that is clear. Now we will think about reducing agent. Now reducing agent means what it will do. Now I am just rubbing this. Now we can think just opposite, nothing else. Okay, so reducing agent, what reducing agent will do? We will just assume what it will do. Okay, now we know that agent, so reducing agent, so the reducing agent will reduce someone. So here if I consider A as my reducing agent, RA, reducing agent, then this person will reduce someone. So we know what is reduction. Reduction means gain of electrons. What is reduction? Gain of electrons. So we can say B has gained electrons. So from where it has got electrons? Gained electrons. Why? Because A performs reduction on whom? On B. So B has, because of that, B has gained electrons. So if B is gaining electrons from A, what happened to reducing agent? It has lost electrons. So a reducing agent will lose electrons. So very simple. During reduction, reducing agent will do reduction on someone. So a person undergoing reduction will gain electrons, and the person who performs or who behaves as a reducing agent will lose electrons. Now how I can now rewrite this formula? So this formula is for oxidizing agent. I am now going to write it for reducing agent. Equivalent mass of a reducing agent. Okay, so So equivalent mass of a reducing agent, how I can write? Molecular weight by number of electrons. What happened to reducing agent? It has lost. So I can say, instead of gained, I can say lost by one molecule, because it is for reducing agent. Right now I am writing the formula. So I hope you got a fair idea. Very simple. Oxidation means, the process oxidation means loss of electrons. The process reduction means gain of electrons. Reducing agent will lose electrons. Oxidizing agent will gain electrons. That's it. Now let's see an example here. Now in this example you could see zinc, copper 2 plus, zinc 2 plus, copper. So we could see here. Now zinc, during this reaction we will check out the oxidation number. So with the oxidation number we can easily identify who performs as a reducing agent or who performs as an oxidizing agent. Okay. So zinc, if for any element in its natural form, has its oxidation number 0. This you will learn in detail in a chapter called redox reaction. Okay. So here zinc, it is in its elemental form. So its oxidation number is equal to 0. Now during the process, what happened to zinc? Just to see that its oxidation number, now for a charged species, always the oxidation number is equal to that particular charge. Now here, if you see the oxidation number, so what is the oxidation number here? It is plus 2. Now you tell me what happened here. From 0 to plus 2, it has increased the value. From 0 to plus 2, it has increased. So if oxidation number is increasing, so what happens to the zinc then? Very easy. If oxidation number is increasing, please remember, oxidation number is increasing means that species has underwent oxidation. Very easy. If the oxidation number is increasing, that species has underwent oxidation. Now you can think about that logically also, because oxidation number is increasing means what is happening? Plus 2. Plus 2 means actually what? Loss of electrons. We know in oxidation, loss of electron will happen. In that way also you can think. But easier way is, if oxidation number is increasing, that species has underwent what? Oxidation. So if this guy has underwent oxidation means what actually? It is losing electrons, right? Oxidation means it has lost electrons. So who will lose an electron? Reducing agent. So actually zinc is now here behaving like what actually? A reducing agent. So very simple, a reducing agent will undergo oxidation. An oxidizing agent will undergo what? Reduction. That is the easiest way to remember. Okay. Now think about this case, copper 2 plus. So its oxidation number is plus 2. Okay, now what is happening to copper here? Its elemental state, so its value is 0. Now you can see plus 2 is decreasing to 0. From plus 2 it is decreasing to 0. That means oxidation number has underwent decrease. So if oxidation number is decreasing, then the process is what? Reduction. If copper 2 plus underwent reduction means what is the easiest way? Reduction, if it is undergoing, then it should be what? It should be an oxidizing agent. Okay, so because from plus 2 to 0, what it should do? It is reducing from plus 2 to 0. Actually from plus 2 to 0, what it should do? It should gain electrons. So gain electrons means what actually? If it is gaining electrons, then that means the process is reduction. That is why I am showing here. This underwent a reduction, so that this forms a reduced product. Okay, so if it is undergoing reduction, so that means it is gaining electron. So it is gaining electrons means what? It is oxidizing someone. So who is him? Copper 2 plus oxidizing zinc. So I can say copper 2 plus here is an oxidizing agent. I hope this is clear for you. If you are not getting an idea, please revisit, please re-look into the video one more time. You will get a fair idea. Okay, finally I will tell a conclusion for this. Okay, now the final shortcut to remember that is very simple. Oxidizing agent is there. So OA means oxidizing agent. So easy to remember. Oxidizing agent undergoes. Just to take the opposite of this. Oxidizing agent, if agent is there, you take the opposite of oxidation. What is that? Oxidizing agent undergoes reduction. Reduction. Easiest way to remember. Now, reducing agent. So, reducing agent. So tell me, very easy, reducing agent is there. So if he is an agent, then he will undergo just opposite of this. Reducing, opposite means undergoes oxidation. Easiest way to remember. Okay, this you will see in detail in the chapter redox chemistry. So right now we have understood what is equivalent mass, we have learned what is normality. Now we will do some problems on normality to make you comfortable. Okay, please go through the question. Question is very simple. Find the normality of 0.4 gram of NaOH present in 40 ml of solution. So how to do this actually? So first we will define what is normality. Okay, tell me what is normality. We have learned. So normality, molarity is what actually? Number of moles of the solute divided by volume of the solution in liters. Correct. So similarly, number of moles, instead of number of moles, what we will write here? Instead of number of moles, number of gram equivalents. Number of gram equivalents of the solute divided by volume of solution in liters. Hope you remember. Okay. Now next question is how to find the number of gram equivalents of the solute. This is what we were trying to learn. Okay. So how to do that? So number of gram equivalents or number of moles, how you are finding? Weight in gram by molecular mass. So similarly, number of gram equivalents, how to find out? So who is the solute here? NaOH. So the number of gram equivalents means weight in gram of NaOH. How much is that? 0.4 divided by equivalent mass of NaOH. Now tell me, it is a base. How to find the equivalent mass? Equivalent mass of a base is equal to molecular mass. Molecular mass of NaOH is 23 plus 1 16, 39 plus 1 40. Okay, 40 divided by number of replaceable OH minus ions, or you can say acidity. So how many OH minus ions are there? 1. So I can say molecular mass divided by acidity, that is 40 by 1. So its equivalent mass is equal to 40 itself. So for NaOH I can say equivalent mass and molecular mass are the same. So I can substitute that 40 then divided by volume of the solution in liters. Here however 40 ml is given. So what should be done to convert this into liter? So I know that 1 liter is 1000 ml. So 1 ml is equal to how much? I know 1000 ml. To make it 1 ml, I will divide by 1000 here. So here also I will divide by 1000. So it will become 10 power minus 3 liter. What I have done, divided by 1000 here, divided by 1000 here. So that 1000 will come on the numerator and it will become 10 power minus 3 liter. So I can write volume of the solution is nothing but 40 ml. But 1 ml I know this much liter. So 40 into 10 power minus 3 liters. So calculate this, how much it will come. So here I am dividing on the numerator and denominator by 10. So it will become 4 by 400 divided by, this will become 4 into 10 power minus 2. So this I am doing, it will become 1 by 100 into, so 4 into 10 power minus 2. So what will be its answer actually? So you can take 10 square on numerator, so it will get cancelled. So my answer will come as 1 by 4 normal. Okay, so I hope you have got a fair idea. Very simple. Always remember, normality means number of gram equivalents, molarity means number of moles. Moles means weight in gram by molecular mass, gram equivalents means weight in gram by equivalent mass. We have learned how to find the equivalent mass. And also please remember, sometimes there instead of gram equivalents they say equivalents. That is also correct. Don't worry about that, because since we say weight in gram, they are explicitly saying gram equivalents. Then some students used to say, sorry, then we should say gram moles. Correct, actually speaking we should say gram moles, but we are still saying number of moles. So number of gram equivalents is also same as number of equivalents of the solute. Okay, so I hope you understood. We will go to the next important term of concentration. So listen, so the next term what we are going to learn here is called the concept of molality. Concentrate, molality. Okay, LITY, molality. It is represented by the letter small m. And how we can define this? Okay, so molality is defined as the number of moles of the solute, present in 1 kg of the solvent. That is called 1 molal. Okay, so here important thing to remember here is 1 kg of the solvent. Until now we were speaking about solution, now it is solvent. And we should remember here, it is not the volume. In molarity and normality we were speaking about volume of the solution, but here we are talking about mass of the solvent. So since it is depending only on the mass, I can say molality is independent of temperature. Very important point. Independent of temperature. Why? Because volume terms have a direct relationship with temperature. If it is mass, means that is always fixed, that does not depend on temperature. Okay, so it is very easy to remember. In your formula, if you have only mass terms, surely it will be independent of temperature. If you have volume terms, then I can say it will depend upon temperature. Okay, very simple. So right now we have defined very simple number of moles of the solute divided by amount of the solvent in kilogram. So if I want this to be 1 molal, what should I do? I will make the amount of solvent as 1 kilogram. Then this will become 1 molal. Okay, so I hope you understood what is molality. Now we will try to do one question based on molality. Okay, so please go through the question. If 18 gram of glucose is present in 1000 gram of the solvent, then find out the molality of the solution. This is a question. So which is the solute here? Glucose. So I know glucose is nothing but what actually? C6H12O6. Correct. So how much amount of glucose is present as the solute? 18 gram is available. Okay, so we know given is 18 gram. Clear? Now what is the molecular mass of the glucose? We know. So how we can do that? 12 into 6 plus 1 into 12 plus 16 into 6. So if you calculate it, you will get it as 180. Okay, now very important. Now solvent, what is the mass of the solvent given? So mass of the solvent, we don't know which is the solvent, but they have given mass of the solvent as 1000 gram, which is nothing but 1 kg. Okay, now what we need to do? We need to find out molality. Now please remember here, in questions like this, they have here directly given the mass of the solvent. Sometimes they will give only mass of the solution. In that case, what we need to do? You need to remove the mass of the solute from the solution so that you will get mass of the solvent. Because we know that mass of the solution is the sum of mass of the solute plus mass of the solvent. Okay, but in this question they have directly given 1000 gram is the mass of the solvent. Okay, so let us apply this in our formula. Now how to find molality? Tell me. So molality small m is equal to number of moles of the solute. So we know number of moles of the solute is nothing but weight in gram, that is 18 gram, divided by molecular mass 180. So I know now weight in gram by molecular mass, that is my number of moles of the solute. Here solute is glucose, divided by mass of the solvent in kilogram. I know 1000 gram is nothing but 1 kilogram. So I can write 1. So 1 kg it will come. So my answer will be how much? 18 by 180. 18 by 180. So 180 can be written as 118 into 10. So this will get cancelled out and I can say I got an answer 0.1 molal. Small m. Please remember you should write small m. 0.1 molal. I hope you understood this concept. Now we will go to the next important concentration term. Okay, now we will see the definition. So mole fraction, it is represented by X. Okay, so we will define what is mole fraction. So you understood it is some moles and its fraction. Okay, so the definition also says that, suppose consider a solution. We know that a solution, now we are talking about a solution that is a binary solution. Okay, you have a solute and a solvent, nothing else. Now how will you define mole fraction? Very simple. If I want to define the mole fraction of the solute, I can say the mole fraction of the solute is equal to number of moles of the solute divided by total number of moles of all the components in the solution. So other way how I can write total number of moles of all the components, I can say number of moles of the solute plus number of moles of the solvent. Okay, so similarly if I want to write mole fraction of the solvent, how I will write? Very simple, number of moles of the solvent, because fraction of solvent we are finding it out. So number of moles of the solvent divided by total number of moles of all the components present in the solution. Again, total number of moles of all the components means number of moles of the solute plus number of moles of the solvent. Now if you think, just you add mole fraction of the solute plus mole fraction of the solvent, what will happen? Denominator is same. Correct. So numerator will get added up and that will become equal to the denominator and its value will become, on cancellation, its value will become 1. So please remember always the mole fraction sum. So I can say mole fraction of the solute plus mole fraction of the solvent in a binary mixture, in a binary solution, it is equal to 1. It can be anything. Okay. So that is like fraction. Always this mole fraction will have a value, solute or solvent, its value will always be less than 1. So when you add those fractions, at the end of the day you will get 1. It can be, it will, now here I have taken two things, solute and solvent. We can take it as A, B, C. In that case mole fraction of A will be number of moles of A divided by total number of moles. Then I can say number of moles of A plus number of moles of B plus number of moles of C. Similarly, then mole fraction of B will be number of moles of B divided by number of moles of A plus number of moles of B plus number of moles of C. And mole fraction of C will be number of moles of C divided by number of moles of A plus number of moles of B plus number of moles of C. Again, if you are adding all these, again you will get the sum as 1. So that is always you need to remember, always the sum of the mole fraction of all the components. If you are adding the mole fraction of all the components, its sum will become always equal to 1. Okay, I hope you understood. So here also only the mass terms are only involved, because number of moles means weight in gram by molecular mass. Here also weight in gram by molecular mass. So surely mole fraction mass terms are only involved. Then I can say mole fraction is independent of temperature. Understood? Independent of temperature. So how will you define mole fraction? It is defined as the ratio of number of moles of that component, mole fraction of which component, to that of that component, to the total number of moles of all the components present in the solution. Okay, so I hope you understood, you got a fair idea on what is this actually. Okay, so always remember this. So if suppose you know the mole fraction of the solute here, you can easily find the mole fraction of the solvent. What you need to do, you do 1 minus mole fraction of the solute. So easily you can get mole fraction of the solvent. So similarly, if you know mole fraction of the solvent, how you can get the mole fraction of the solute? 1 minus mole fraction of the solvent. Easily you can get it. So we will do one question based on this and then we will go to the next term. Now please go through the question. The mole fraction of oxygen in a mixture of 7 gram of nitrogen and 8 gram of oxygen is. So now you understand what is the mixture here. So mixture is made up of what and all things? That is the first thing to understand. How many components are there in the total mixture? So I know that the mixture is made up of two things. One is nitrogen. The other person is nitrogen plus oxygen. Okay. Now which one they are asking you to find out? They are asking you to find out the mole fraction of oxygen. So let me say I will represent the oxygen's mole fraction as XO, and nitrogen I will represent it as XN. Okay, but in the question they have asked only XO. Okay, so I may say the mole fraction of oxygen, how you can define as per you are learning right now, you have learned it, right? So I can say the number of moles of oxygen divided by total number of moles of all the components in the mixture. So who are the thing? Nitrogen and oxygen. So I can say number of moles of nitrogen plus number of moles of oxygen. Correct. Now what we need to do? We need to find out what is number of moles of oxygen. Okay, so how you can find the number of moles of oxygen? Tell me. Think. We have learned number of moles from our 11th standard onwards. So number of moles is how much? Weight in gram by molecular mass of oxygen. Okay, now here we know oxygen, it exists as a gas. Okay, so how much gram they have given? They have given 8 gram of oxygen. So weight in gram is how much? 8. Okay, divided by the molecular mass of oxygen. We know one oxygen atom constitutes 16. So O2 means 16 into 2, 32. So weight in gram by molecular mass. Okay, so similarly number of moles of nitrogen, how you can find it out? Weight in gram of nitrogen. What is the weight in gram of nitrogen? Tell me. So they have given 7 grams. So 7 divided by molecular mass of nitrogen. Nitrogen exists as N2. That is one nitrogen atom will have a mass of 14. So 2 nitrogen atom, 14 into 2, 28. So I can say 28. Plus number of moles of oxygen that we already calculated, that is 8 by 32. So tell me what will be the answer? So 8 will cancel with 32 as 1 by 4. Okay, this will also get cancelled as 1 by 4. This will get also cancelled as 1 by 4. So tell me what is 1 by 4 plus 1 by 4? It will become 2 by 4, that is nothing but 1 by 2. So my final answer is 1 by 4 divided by 1 by 2. That is how much? I can say that is nothing but 2 by 4, that is 1 by 2, or I can say answer is 0.5. So I can say the mole fraction of oxygen is equal to 0.5. Now tell me what will be the mole fraction of nitrogen. Do I need to find it like that? Number of moles of nitrogen divided by number of moles of nitrogen plus number of moles of oxygen. Do I need to find like that? No, because there are only 2 components. Then I know that what I know? I know that X of nitrogen, mole fraction of nitrogen plus mole fraction of oxygen is equal to 1. So I right now have found out what is mole fraction of oxygen, that is 0.5. Okay, which is equal to 1. So I know that the mole fraction of nitrogen is equal to 1 minus 0.5, that is equal to 0.5. Mole fraction of nitrogen is 0.5. So but in the question they have not asked this, but just I was explaining to make you understand that I don't want to find again one more time, because this is only made up of 2 things. Suppose it is made up of 3 things, then we need to find the first 2, then for the third one you can subtract 1 minus the sum of other 2. Okay, so I hope you understood this concept of mole fraction. Then we will go to the next unit. Okay, next concentration term. So next we are going to learn, we say concentration in terms of percentage. So instead of saying 1 by 1, I have given here a combined approach that will help you to remember. That's why. Okay, so the first term we are going to learn is percentage by mass. So percentage by mass means very simple, mass of the solute divided by mass of the solution. Both are mass terms. Mass of the solute divided by mass of the solution. So this mass of the solute divided by mass of the solution is called mass fraction. What is that? Mass fraction multiplied by 100. That will give you percentage by mass. Very simple, take the mass of the solute, take the mass of the solution. So you know both terms are mass. So I can say mass fraction is, or percentage by mass is independent of temperature. Now here, what is percentage by volume? Similar way you can say volume of the solute divided by volume of the solution. Then volume of the solute to the volume of the solution. That term alone is called volume fraction. So I can say another formula is volume fraction into 100 will give you percentage by volume. Okay, now it's a mixture actually, percentage mass by volume. So mass by volume means mass of the solute. So first mass, so mass of the solute, that is in gram, divided by volume of the solution, that is in ml, multiplied by 100. There is no specific term for this one, that's why it is not chosen there. So just remember, mass of the solute in gram divided by volume of the solution in ml multiplied by 100 will give you percentage of mass by volume. Okay. Now why there is no unit here? Because these are all fractions. We know that fractions or ratio does not have a unit. So I hope you understood this. Now we will do some questions based on this. Okay, to make it more clear.